words I want you to remember today. The first word is and. The second word is or. Now we will get to or in a little bit, but we're going to focus on and right now. And in mathematics means intersection, means where two things intersect, what's in common. And so first of all, what we're going to do is we're going to look at how would we graph this inequality right here. Okay. How would we graph this inequality right here? And so notice I have 3 number lines. On the first number line, I'm going to graph x is greater than or equal to 1. On the second number line, I'm going to graph x is less than 5. On the third number line, I'm going to graph x is less than or equal to 1, and I said less than, I meant greater than, sorry. X is greater than or equal to 1, and x is less than 5. So now what I'm going to go ahead and do is I'm going to start with 0, because if you remember, I always start with 0. And notice how I'm kind of lining up each of the marks. That's what I want you to do. So on that top line, if some of you already have it done, I want you to go ahead and graph for me x is greater than or equal to 1. So what will I do? For x is greater than or equal to 1. Draw, okay, close circle on 1. Which way will I shade? Good job. Okay. Now, x is less than 5. What will I do? 5? Open circle. Good job. And then shade which way? To the left. Now, when I think of the word and, I think of the word intersection. So I'm looking for what's in common with these two graphs. So basically my answer has to be shaded in both the purple and the light blue graph. So let's look at the left arrow. Is the left arrow shaded in both graphs? No, because it's not shaded in the purple, right? Is 0 shaded in both graphs? No. Where's the first point that is shaded in both graphs? 1. Is 2 shaded in both graphs? What about 3? What about 4? What about 5? No. 5 is not shaded in the bottom graph. So we're going to use an open circle there. Okay? So with and, you're looking for what's in common. What's shaded both ways. Now, of the two, okay, remember I said we're also going to graph this inequality, which means an intersection. I will tell you right now that you will actually like the second one. And so what we're going to do right now is I'm going to reset the page, and we're going to go ahead and graph this second inequality. So I've got 0, 1, 5. So this is how you graph that one. This number here tells you where you're going to start. So I'm starting at 1. I am looking at the inequality right next to 1. So I'm looking at this inequality. Does that symbolize a closed circle or an open circle? Closed. Okay. Now I'm going to go to the other side. This tells me where I end. I'm going to go to the inequality right next to it. Does that use a closed circle or an open circle? Open. Now, the rest of this says that x is between those two values because x is in the middle, kind of like a sandwich. So all I'm going to do is shade in between. And that's it. And that is the exact same graph as what we just looked at. Okay. So let's look at an example. Solve the inequality, then graph the solution set. Now, if you notice, this is kind of one of those sandwich ones again, where x is in the middle. So what I want to do is I want to get x all by itself. So in order to get x all by itself, I have to get rid of the negative 3. So what undoes a negative 3? Adding 3. So I'm going to add 3 here. I'm also going to add 3 on the left. And I'm going to add 3 on the right. So what is negative 2 plus 3? 1. Less than or equal to. What happens to my 3's? And I'm left with 4 plus 3. What do I get? 7. So if you remember, this is just like the sandwich. And so I'm going to start with 0. Now, I'm going to look at this number. This number tells me my ending point. Am I going to use a closed circle or an open circle? Closed. Where's my next ending point? 7. Am I going to use a closed or an open? Open, because this is not equal to. And then what am I going to do? Shade in between. Okay. So far, so good? All right, let's look at another one. So now this one's a little different than the previous one we just looked at. So basically I've got 2 inequalities I'm going to solve. What do I do from this first one? Add 3 to both sides. So really I get y to be greater than or equal to what? Negative 4. So that's what I'm going to graph on my top line. Now I'm going to go ahead and solve that other inequality because I don't know yet how far my number line is going to go left or right. So here, what do I do to solve this? I add 3 again. So I get y to be less than or equal to what? Negative 1. And so those are kind of like my boundaries. And so I'm going to go ahead and graph y is less than or equal to negative 1. And so if I look at this, here's 0. Okay. So let's start with y is greater than or equal to negative 4. What type of dot on negative 4? Closed, and shade which way? To the right. Okay. What about y is less than or equal to negative 1? Closed, shade which way? Okay. So my final answer will look like what? Okay. Good job. Yep. Nice job. So that is going to be your final answer. Questions? Yes?
Do you have to have Mr. Isaac? Can you just...
I'll show you. I'll show you. You are going to probably need to put 3 arrows, and I'll kind of show you another way where you don't have to actually do 3 number lines. Okay. Let's look at another one here. Okay. So what am I going to do to solve that? What? Get rid of the 7. So what am I going to do? Subtract 7. So I end up getting negative 1 is less than r is less than 3. So we've got 0. Oh, less than or equal to. Okay, good. There you go. Okay, so I've got 0, -1, and then 3. So what type of circle on -1? What type of circle on 3? Which way do you shade? How about in between? Okay. By just saying left, that means I would probably go beyond the left line, but actually it's just in between those two values. So those are the and statements. And means what again?
Intersection.
Intersection. Good. So now we're going to talk about the or. Because if you remember, I said 2 words. And was the first, or was the second. Or means union. Union is different from intersection. And we're going to look at how it's different on this first example. So I'm going to do x is greater than 2. Then I'm going to do x is less than or equal to -1. And then I'm going to do x is greater than 2 or. So if I do my number line, I'll do 0 here, do -1 here, and then I'll do 2 here. So now x is greater than 2. What can you tell me about that graph? And shade to the right. Okay. X is less than or equal to -1. Okay. Now with union, it just matters that it's shaded in one. It can be shaded in both, but it just has to be shaded in one for you to shade the answer. So if I look at the left arrow, is the left arrow somewhere shaded? Yep, it's shaded in the light blue, so I'm going to shade that. Is the -1 shaded? Yep. Is the 0 shaded? No, the 0 is not shaded. Is the number 1 shaded? No. Is the number 2 shaded? No, but I'm going to use an open circle, and then I'm going to shade all the way to the right arrow. So with unions, it just matters that it's shaded in one. Can be shaded in both, but it has to be shaded in at least one for it to be in the answer. So let's go ahead and look at an example of union. Now you're going to notice that these are going to be getting a little more in depth, and you're going to probably have to solve them using more than one step. So let's start with the first one. What am I going to do first? Subtract 7. Good. So I get -2m to be less than or equal to 6. What do I do now? Divide by -2. Now when I'm dividing by that -2, you should automatically have like a little alarm that's going off. You just divided by a negative number. So you've got to flip that inequality. So I get m to be greater than or equal to negative 3. So that's my first statement. Now I'm going to solve the second inequality. So I'm going to subtract 12. So I end up getting 5m to be greater than what? 25. So if I divide by 5, what do I get m to be greater than? 5. So now what I'm going to do is I'm going to go ahead and have on my graph a negative 3. I've got to have my 0. And I'm going to show you how I usually graph these all on one graph. Okay, I start with the m is greater than or equal to negative 3. So that means that I would put a closed circle and I would shade this way. Okay? When it says m is greater than 5, I know that means I've got an open circle and I'm going to shade this way. So then now I'm going to combine both of these onto my final answer. So is the left arrow going to be shaded? No. Is negative 3 going to be shaded? Yeah. Is negative 2 shaded? Negative 1? 0. 1, 2, 3, 4, 5. Why do I shade 5? Because it is shaded up above. Okay? Remember, it only has to be shaded in one, and the 5 is shaded in the purple. Okay? All right. Let's look at another one. Okay, last one we're going to look at today. Now this one is kind of nice because the first inequality is already solved. You don't have to solve it, it already says what it is. So what am I going to do? Subtract 2. So I get 4x to be less than 8. What do you do now? Divide by 4. So I get x to be less than what? 2. So my boundary points are kind of like 9 and 2. But remember, I always need to have 0 on my number line. Oh, it's black. So here's 0. There's 2. There's 9. So let's start with x is less than or equal to 9. That means I'm going to have a closed dot on 9, and I'm going to shade left. X is less than 2 means you're going to have a open on 2, shade to the left. So let's start. Am I going to shade the left arrow? Yep. Am I going to shade 0? 1, 2. There we go. All the way up to where? 9. Nice job. So any questions? Real quick, I want to look in your book. Okay, there's your assignment, but we need to go ahead and look at a problem. So page 309. Okay. So on page 309, or 308 and 309, 6 through 15. So let's go ahead and I want to look at problem 24. Okay? I want to look at problem 24. Now on problem 24, this is what they give you. They give you that 3b plus 2 is less than 5b minus 6 which is less than or equal to 2b plus 9. Now, in this case, since you have variables on all three parts of the inequality, you're going to solve this a little different. Okay? You're actually going to split this apart into two separate inequalities. And this is how you're going to do it. I'm going to look strictly on the inequality to the left. Okay? So you see that inequality is 3b plus 2 is less than 5b minus 6. So do you see where that came from?
Yeah.
Okay, and is my connector word. Now I'm going to look at the inequality on the right, and I'm going to leave off the left one. So that will be 5b minus 6 is less than or equal to 2b plus 9. That's what you're going to need to do on those ones if they have a variable on all three parts. Okay, so need you to go ahead and work on that.